All right, guys, we are on chapter 3, section 3, and we're going to talk about ionic compounds. And so, if you remember, we talked about in the last section, gaining and losing electrons. Well, it's all good, it's all true, but if you've gained an electron, where did that electron come from? And if you lost an electron, where did that electron go? And so, really, when we make ions, it's really usually a metal and a non-metal, and the electrons are transferred. So whichever one of the atoms is losing the electron, the other atom gains it, right? And so that's where those electrons come from. And we call these ionic compounds. So if you gain or lose, give and take, that tells you it is ionic. And so you now have in this ionic compound something that's positively charged and something that is negatively charged. And the two charges balance each other out so that the net result is you have a neutral compound. Okay, so let's take this one step at a time. If you have, for example, sodium. So here's our example. We have sodium. Sodium is in group, if I can do this, group 1A. So how many valence electrons does it have? It has one valence electron. So what we're showing is a sodium atom here, and we're only showing valence electrons. And so we give it one dot because that's the valence electron. Chlorine, on the other hand, is in group 7A. If you're in group 7A, you have 7 valence electrons. So we said previously that chlorine wants to gain 1 and sodium wants to lose 1. Oh, look, isn't that awesome? We can take sodium's 1 valence electron and we can transfer it, and we can give that 1 electron to chlorine. So now chlorine has gained an electron, sodium has lost an electron. And so now sodium's positively charged. It has a positive 1. This has a negative 1. And so you have these two ions. They're oppositely charged. So think about magnets, right? If you have oppositely charged magnets, what are they going to do? They attract to one another. And that's exactly what happens in an ion formation. When that electron moves, you now have something that is positively charged and something that is negatively charged. So now they're attracted to one another. And so that attraction between the ions is the ionic bond. That is the definition of an ionic bond, the attraction of a cation to an anion. And so now we have an ionic bond. And so we name this, now it's no longer just naming our ions. It's not the sodium ion and the chloride ion. It's sodium chloride. And so the way that we do this is we name our ionic compounds. We always say our metal first, our metal, then we say our non-metal. And so for our metal, we just say the element name. And then for the non-metal, we say the element, and then we add that IDE. So there it is, chloride. And this is table salt. This is what you put on your food. So when we look at this compound, now we have the attraction between the two oppositely charged particles. We have a positive 1, we have a negative 1. Overall, if we take into account all of this, what is the net charge? Well, I have a +1 and I have a -1. What do I get? Ooh, I'm covering it. +1 and a -1. I get 0. So my net charge is 0 on all ionic compounds. Must be 0. That is the definition, right? So let's try a different one, because your book only kind of gave one there. So let's try to make an ionic, this is an ionic compound with calcium and chlorine atoms, right? This one's kind of not done for us yet. So let's take calcium. Calcium is Ca. How many valence electrons does calcium have? So if you went and looked on the periodic table, you would see that calcium has 2 valence electrons. How about chlorine? Here's chlorine. Go on the periodic table. How many valence electrons? I'm sorry, I didn't say. Calcium is in group what? Group 2A. So that's how we know we have 2 valence electrons. Chlorine is in group 7A. So we have 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. All right, what do they want? They want an octet. So chlorine is going to take 1. Calcium wants to give up 2. Well, this is pretty nice, right? Calcium's got 1 here that it wants to give up, and chlorine needs 1. So this chlorine is happy. But is calcium happy yet? It's not. It still has 1 valence electron, and that's not a complete octet. So what are we going to have to do? We need another chlorine atom. So let's draw another chlorine atom. And this chlorine atom also has 7 valence electrons. That's just kind of how we draw it. We draw it with the atom and we put them individually one at a time, and then we start doubling up on them. So what are we going to do? Now calcium can give up its second electron and give it to another chlorine atom. So to make the overall charge of an ionic compound that contains both calcium and chlorine, you need 2 chlorine atoms for every 1 calcium atom. And that's what we're going to do when we write a formula. We're going to say we need 1 calcium and we need 2 chlorine. But you don't want to have to draw this out every time. That's going to get super time consuming. So let's find an easier way to do that. If I know that calcium has a charge of 2+ because it's in 2A, and I know that chlorine has a -1, you can put a minus or you can put -1, doesn't matter to me. I'm going to show you a trick. The trick is, it's called the crossover. You take the charge on 1, and we're always going to start with our metal on this side, our non-metal here. So you take the charge on the metal, and that becomes the subscript on the non-metal. And then vice versa. You take the charge on the non-metal and make that the subscript of the metal. And so what does that give me? That gives me Ca1, but I don't write a 1, Cl2. Okay? So this would be calcium, because that's our non-metal, that's just our name. And then we have chlorine, but we can't say chlorine. We're going to say chlor, C-H-L-O-R-ide, chloride. Okay? So it's crossover. That's what we call a crossover. The only thing that you have to worry about is what if you had something that was where you had 2 of the same charge. So let's go to our periodic table. Oh, any periodic table would be good, right? And let's pick something like calcium, and we're going to put sulfur, calcium and sulfur. So calcium's a 2+, sulfur's a 2-. So let's try that, and let's see what happens with our crossover. So we said calcium is a 2+, sulfur is a 2-. Let's do our crossover. The charge on the calcium becomes the subscript for the sulfur. Charge on the sulfur becomes the subscript for the calcium. So if I were to write that, that would be calcium 2, sulfur 2. But we don't write it like this because this can be reduced. So just like you reduced a balanced chemical equation, right? You reduce your formulas for your ionic compounds. And so what can you do to both of these? You can divide them by 2. And so that's Ca1, S1. So this is calcium, sulf, and remember this is just an element, just an ion, sulfide. And the reason this works is because your overall charge is going to be 0, right? Because if you look at calcium, if you have, here's our final formula, if you have 1 atom of calcium and each one is a +2, excuse me. If you have sulfur and you have one sulfur atom, that's the subscript, and we have a charge of -2. What's your overall charge going to be? A +2, a -2, that equals 0. We have a great ionic compound there. Let's check our other ones. Calcium 2+, so we have one atom that is a 2+. Then we have chlorine, we have 2 atoms, and it is a -1. So we get a +2, we get a -2, gives us an overall charge of 0. We wrote our ionic formula correctly. Okay? So make sure your overall ionic formulas give you a charge of 0. And the way to do that is to cross over and reduce. Easy, easy, easy. Cross over and reduce. Okay. So this is just words from what we just did. The number of ions that combine to form an ionic compound is determined by the charge, right? That tells you how many valence electrons are going to have to be moving around. So we're going to combine our cations and our anions to make a net charge of 0. That is super important. And when we write them, we represent the number of each atom with a subscript, right? So we said, for example, here we had one calcium atom. Calcium atom. And then we have 2 chlorine atoms, right? So our subscript tells us how many. And then the charges of the formula, the charges of the individual ions in the formula, we don't show them. So when we were writing them, we were trying to figure out how to do it, we showed them, but in our final, so you had like calcium chloride, CaCl2, right? If you had NaCl, I'm not writing charges there. This is my final answer, and so I don't write a charge because the overall compound has a charge of 0, so we don't write it there, right? Okay, so this is another example, right? Determine, this is kind of your stepwise, determine the charge of the ions from the periodic table. So aluminum, if we went and looked for aluminum, aluminum is in group 3A. So I know that all group 3A elements are going to give me a charge of +3. I go to my oxygen. Oxygen is in group, what? 6A. If it's in group 6A, go look on the periodic table, you know that it's going to have a charge of -2. So all they did was take the charge on the aluminum and put it as the subscript for oxygen, take the charge on oxygen, put it as the subscript for aluminum, right? So cross over, and then can we reduce? No, we can't reduce. So we're good. So we have, for every 2 atoms of aluminum, we have 3 atoms of oxygen. Pretty nice and easy. All right, let's see. So remember that your formula for your ionic compound has no net charge. All the positives and negatives have to add up, right? And we always start with our charge of our anion, because sometimes you can have transition metals, and those transition metals can have different charges. And so if you always start with the anion, you're gonna get it right. Okay, so now that we can write the formula, we have to be able to name it, just like we did with the ion. We wrote the symbol, and now we name it. So to name an ionic compound, what you're going to do is you're going to take the names of the 2 ions, and you list the cation first. So this is how I like to think about it. Good news first. Good news first. I always like my good news first. So positive, then give me the bad news. And that's our negative, right? So when you're writing your formulas and writing your names for ionic compounds, always start with the good news, which is the positive, and then do your bad news, which is the negative. Okay, and you don't say the word ion. So NaCl is sodium chloride. Sodium's a +1, chlorine's a -1, and so you know to start with the sodium and end with the chloride. And we just don't say the ion part. For transition metals, right? Just like we did in the ion, we're going to use those Roman numerals. So copper, So copper, if we don't know the charge, because we said copper is kind of one of those transition ones that can have multiple. I know my oxygen, so if I have Cu and I have O. When I go to the periodic table and I find oxygen, so go to the periodic table, we find oxygen. Oxygen right here is in group 6A, so it's going to have a charge of -2. But I see my copper right here is a transition metal, so I can't automatically give it a charge. I have to say, I don't know. And I know my oxygen is a -2. Okay, and I don't know what this is. So I'm going to do my crossover. I'm going to take this -2 and I'm going to put it down here, -2. Now, I also want to take my other one and cross it over, right? But I don't know what that is. So what could my oxygen be to give me this formula? I know I'm going to have to end up with CuO. So what's going to have to happen in between? Well, let's look. So we know we're going to have Cu2O something. How am I going to reduce that to CuO? Well, that means I have to have Cu2O2. And then that reduces to CuO. Okay, so that can be, the transition metals can be kind of tricky, and we'll do some examples. If you have a polyatomic ion, when you see the polyatomic ion, all you have to do is say its name. So this would be Ca3PO42. Looks like you got a lot going on, but it's super easy. Calcium, and then you would just have to say, ooh, I see that's a polyatomic, it's in parentheses. All I'm gonna have to do is find it in a table. And so there are tables in the textbook, and you'll get the tables on the exam. Okay, and I think that's our last slide. Yep, from there. So we're gonna switch over and we're gonna go do some problems. So here we got our problems. How many electrons, oh no, we did that. I want the one where we started working already. Here we go. Gotta find the right file. Here we go. 3.3, ionic compounds. Okay, so give the formula and the name for the ionic compounds formed from the following pairs of ions. So we need a formula and a name. Gold 3 chloride and antimicrobial. So what I want to do is I first want to look at them and I want to give a charge, gold 3. Well, if it's in Roman numerals, I know that's a transition metal. And transition metals are all going to form cations. It's a metal, it's going to be a cation. And this Roman numeral 3 is telling me what the charge is. So this is going to be a +3. Chloride, that's an ion. It's the ion of chlorine. And so it's going to be Cl-, right? So gold is Au. I guess I should have done that, right? Au 3+. Au is gold, Cl is chlorine. So we have gold 3 and chloride. So what's going to happen? I'm going to do my crossover. Au 3+, Cl-. I'm going to take my 3+ and put it there. Take my 1- and put it there. So I end up with AuCl3. So now I have to name it. Remember that you have this transition metal here. Gold's a transition metal. So you have to say that this is gold 3 chloride, right? Gold 3 chloride. Okay, calcium and sulfate used in plaster casts. So I'm going to say calcium. I need to go find it on the periodic table. When I go and look, calcium is right here. How many times have we done calcium? I've drawn on it like 3 times, right? Calcium is a +2. And we had sulfate. Oh, sulfate. I'm going to have to go look at a table that has my polyatomic ion. So I'm going to get calcium. Let me go write that one. Scrolling around in here. Okay. Here we go. Calcium, we said, was a 2+. And then sulfate, you need to go and look it up. And what you're going to find out is that it is also a 2 plus. So it is Ca2 plus and then SO4 2 minus. What did I say a plus? It's a minus. Hello, it's a minus. So now you're going to do your crossover. Take your 2 plus on your calcium, put it down there. And remember, if you have a polyatomic, you're going to put it in parentheses to make sure that that subscript is for the whole thing. So 2. So let's rewrite it. Ca2, SO4, 2. Now what do you notice? You can reduce these subscripts. So we need to reduce them. Whoop, and rewrite it. So that Ca, there's only 1, SO4, and there's only 1. So what you should recognize is that now you do not need those, those parentheses, okay? So just be careful that you reduce, and that if you have a polyatomic and it has a subscript, you put that polyatomic in parentheses. But if you end up reducing it, you take off the parentheses, okay? Magnesium and hydroxide, the main compound found in milk of magnesia. Magnesium, Mg, is going to be a 2 plus, right? It is in group 2A. And hydroxide, you go look in your table, that is OH, and it is a -1. So all you have to do, you have to practice going to those tables and pulling that information out. So now we're gonna do our crossover and reduce. So I'm crossing over, and I'm gonna rewrite Mg, I'm not gonna write the 1, and I'm gonna write OH, but oh look, I have a subscript, so I need to put my OH in parentheses and put a 2, okay? So just take your time and make sure you're identifying the right things. All right, give the number and each type of ion present in the following ionic compounds. Gold 3 and antimicrobial. So when you do this, right, this is what we just did in here. So we had gold 3, we said that was Au and it's 3 plus. Then we had Cl, and that's a -1. So give the number and each type of ion present. And we said that this gives us, we're crossing over, I know I'm doing it again, but it's worth doing, AuCl3. Now, give the number and each type of ion present in the ionic compound. So what I know I have is 1 gold, 1 gold 3 plus ion. And what else do I have? I have that subscript 3 tells me I have 3 chloride ions, okay? And you have to be able to go back and forth between the symbol and the name. Be careful with that. All right, calcium and sulfate used in plaster cuts, right? And we said that that ended up being Ca plus 2, SO4, and that was a -2. And we crossed them over and we reduced and we got CaSO4. So what is that telling me? I have 1 calcium ion. Now be careful here, that SO4 is a polyatomic ion. So you're gonna have 1 SO4 2 minus, and SO4 is, you have to go find it, but you have to know that that's sulfate. So be able to find sulfate on a table. So you have 1 calcium ion and 1 sulfate ion. Yep. Okay, magnesium, we said that was Mg 2 plus, and we had hydroxide OH minus, and so that gave us MgOH2. So I know I have 1 Mg2 plus ion. And I also know I have the hydroxide ion, but how many do you have? You have 2, because that subscript is on the outside of the polyatomic ion. And so that tells you you have 2 of them. All right, let's see, 25. Give the formula and the name for the ionic compound formed from the combination of the indicated metal and carbonate polyatomic ion. Okay, so sodium, go find it on the periodic table. what you should find it is in group 1, so it is a +1 charge. So if we have that sodium is a +1 and we have carbonate, CO3, 2-, and it doesn't matter if you put the positive and the negative on either side, it doesn't matter. So I'm going to do my crossover. I'm going to take my 1 and put it down here. I'm going to take my 2 and put it there. So I get Na2CO3. Now I have to give the formula and the name. So that is sodium. Good news first. We always put our positive. Then we're going to put our negative. In this case, it's a polyatomic, so it's carbonate. Right? They actually told us the name right there. Okay, Fe2. So Fe2+ and carbonate, CO3, 2-. So I'm going to take it and I'm going to crisscross them. And then I'm going to reduce. So Fe2, I got a polyatomic, so let's put it in parentheses, 2, and then I'm going to reduce that to FeCO3. And I don't need the parentheses anymore because they're both 1. So let's name it. Now be careful. This is iron. Remember, it's a transition metal. You saw it had Roman numerals, so you got to keep those Roman numerals. Iron 2 carbonate. Right? All right. Aluminum. Aluminum is Al3+, and we're going to put carbonate, CO3, 2-. We're going to crisscross them. And I get Al2, I have a poly, so I'm going to put it in parentheses, 3. I can't reduce that anymore because I'm looking at this subscript and this one, not anything in the parentheses. Don't go messing with anything in the parentheses. And I'm going to name it aluminum. Now be careful, aluminum. You want to pick the right polyatomic ion name. So carbonate. Okay. All right, let's see. I think we have a few more. Give the number and each type present in the compounds. Oh, but I didn't put them in 3.25, right? Okay, so let's just copy them. We're just going to do this. Okay, we're going to put them right there. All right, so give the number of each type of ion present. So in my first one, I have 2, because here's my subscript, 2 sodium ions, but let's put the symbol. 2 Na, and what was my charge on Na? It was a +1. And then I have 1 carbonate. And if you have to go up and look, you can go up and look. CO3, 2- is carbonate. CO3, 2-. So I have 2 sodium ions, 1 carbonate ion. In the next one, I have 1 iron 2, and so I got to make sure it's an iron 2 ion, and I have 1 carbonate. Okay, let's look at the last one. In the last one, I have 2 aluminum ions, Al. Now be careful. What's my charge here? 3+. And then I have 3 carbonate ions. Okay, so just be careful, go slowly, and make sure you label them correctly. All right, good luck.